If you've learned about quadratic equations or polynomials at school and how to use the factorised forms of those equations to find roots or zeros in order to graph them, or if you've seen the last 5 or 6 videos of mine about polynomials, then this particular video is for you, because I propose to take you to places that I don't believe any school in Australia will take you, and possibly not your school either. I propose to show how to use 6 basic equations to construct all sorts of complex graphs in a very, very simple way, provided you understand those 6 basic equations. So come with me on the journey, and I look forward to showing you some real mathematical skills worth knowing. G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm your host, Graham Henderson. The first thing I want to do is to share with you the 6 basic equations that students in my home state in Australia need to know by the age of 15 or 16. And here they are. The first equation is a straight line, and I'm just going to call it a line. And we're going to write this in the gradient intercept form that you may be familiar with. I'll just draw a little symbol, a little representative graph there of a straight line to remind us. The second one is a parabola. At least that's the name of the curve. The equation, which I'll write in general form, is called a quadratic equation, and of course they give graphs like that. The third that they have to know is a cubic equation. I'll write it in the general form as well. And of course they often take an S shape in form there. Just tidy that up. These first 3 equations they know are called polynomials. The next 3 aren't. They need to understand how to draw circles and how to create equations for circles. The equation is x squared plus y squared equals r squared. I'll just draw a little representative circle. The next one they've got to know is a hyperbola. I'll write a very simple one, y equals 4 over x squared over x, and I'll represent it. These are very quick sketches. A hyperbola looks a bit like that. And the last one they're expected to know is an exponential equation. Y equals, for example, 2 to the power x, where x is up in the exponent position. These graphs, unless they have coefficients pass through 1, they're asymptotic to the x-axis, and they rise rapidly after they cross the y-axis. So they're the 6 basic equations. What we're going to do is to use these 6 equations to construct quite complex diagrams and quite complex equations in a way that I think you'll find quite remarkable, but very simple. Now what I propose to do in the future is present a series of videos explaining how to understand each of those 6 graph types. So that's a fair project ahead, but for the moment I'm going to assume that you are somewhat familiar with them. The second thing I'm going to assume that you're familiar with is this principle, that if I have an expression like this, in other words I have a product of 2 factors making 0, then either this factor is equal to 0 or this factor is equal to 0, because that's the only way we can have 0 as a result, is multiplying some number by 0. If this is 0, then we have the solution that x is worth 2, because 2 minus 2 is 0, If this is 0, we have the solution that x is minus 1, because minus 1 plus 1 is 0. This, of course, is how we find roots of quadratic equations, which this is. It's a wonderful principle, and we're going to use that with those 6 graph types to produce some interesting graphs. Let's imagine that our factors are not simple binomial expressions, like x minus 2 or x plus 1, but a little more complex and connected with those 6 graph types. I'll show you what I mean. If we have the equation y equals 2x plus 1, for example, I can write that as y minus 2x minus 1 is 0. Just remove all the terms to the left-hand side of the equation. This, by the way, if I graph it, is a straight line. Its y-intercept is at plus 1, and its gradient is 2, which means if I go across 1, I have to go up 2 squares to there. If I go across another one, I have to go up another 2 squares. If I go back 1, I have to go down 2 squares, and there's my line. Y equals 2x plus 1. Let's choose a circle. X squared plus y squared equals 4. Now this, of course, is 2 squared, so I know that the radius of the circle is going to be 2. That is, it will go through that point, minus 2 here. The centre of this circle, of course, is at the origin, and there's my circle. Now this equation I can also change by bringing the 4 over this side into this form. Now I want you to particularly study these. This equation describes that straight line. This equation describes this circle. Now look at this equation. Y minus 2x minus 1, that's this one, times x squared plus y squared minus 4 equals 0. This is a rather complex equation. If you expanded all the terms, there'd be x cubed terms and x squared y and xy squared and y cubed and x and y terms and so forth. A very complex equation, but because it's a product of 2 factors equaling 0, then either this must be 0 or this must be 0. If this is 0, it graphs that line. If this is 0, it graphs that circle. So guess what this graphs? It graphs the 2 of them. And that's the principle I want you to understand in this particular video. Let's do it again with 2 other curves. This time we'll draw the graph first. I'm still going to use a circle, but I'll use a circle and an hyperbola. I'm going to use a circle with a radius of 2 units again. And I think you'll realise that if this is a radius of 2, then the point here is going to be the point root 2, root 2. Now, I would like an hyperbola to pass through this point and to travel up the y-axis and along the x-axis, and to do the same through the corresponding point in the 3rd quadrant. What's the equation of this particular hyperbola? Well, we like them in the form y equals c over x, or xy equals c, what would x times y be in this case? Well, x times y would be 2. And that is the equation for this particular hyperbola. Very easy to construct. So how would we graph the circle and the hyperbola in one equation? We would rearrange this to xy minus 2 equals 0. And we would rearrange the equation of the circle into x squared plus y squared minus 4 equals 0. And if we make this product equal to 0, again, we have either that is 0, which graphs the hyperbola, or this is 0, which graphs the circle. It's that simple. Let's try another one, because I like it. This time we'll use two different equations. Remember that the exponential equation goes through plus 1. So it comes along the x-axis and passes up through there like this. This would be an equation like y equals 2 to the power x. Or, because you now understand where we're headed, we'll write it as y minus 2 to the x is 0. Let's create some symmetry by having the exponential travelling in the reverse direction, and that's easily achieved by reversing the direction of the x-axis, as it were, and simply by changing the x to a minus x. And this equation, when all placed on one side equal to 0, looks like that. And let's just make this look interesting with a frowny face, with a parabola doing that, and let's say it passes through, well that's through plus 1, so let's make this go through minus 1. What does an upside down parabola look like? Well, minus x squared would do the job, but we want to shift it 1 unit down, so we do that. That in fact, when x is 0, y is minus 1 is the y-intercept. Now again, if we want to change this so it equals 0, we get y plus x squared plus 1 equals 0. And these three forms of the equation are the ones that we want to use in our complete equation. Let's do it. We're going to write that y minus 2 to the minus x times y minus 2 to the plus x times y plus x squared plus 1 all equals 0. We have three terms this time, three factors multiplying to make 0. This first one gives us this curve. The second one, this equation, gives us this curve. And the third one, which is this equation, gives us this curve. So this complete equation, with x's and y's all mixed together, will actually give us those three curves on the one piece of graph paper. Now I'm going to create a PDF file of some interesting and challenging questions for you. And I'm curious to see whether, if I present you with a graph, you can construct the equation to produce it, or if I give you the equation, you can create the graph. I encourage you to download the PDF file. You'll find the link in the description below this video. And in the meantime, I want you to experiment with the principles that I've been showing you, enjoy your mathematics, and please, if you're not already a subscriber, please subscribe or comment or like this video. All three of those things encourage me no end. Thank you very much for watching.